Welcome everyone to another fast-paced explainer. So today, we're breaking down a brilliant, highly efficient blueprint for building a machine learning project completely from scratch. Listen, if you've ever felt intimidated by artificial intelligence, or maybe you thought you needed, months of heavy mathematical study to get a working model off the ground, well, you're in exactly the right place. We're going to look at the specific steps to go from absolutely zero to a predicted house price output, and we're going to do it in record time. It's fast, it's highly focused, and it completely demystifies the entire process. Listen to this quote translated straight from our source material. Today we will build our first machine learning project in just 15 minutes using Python. That's a massive hook, right? I mean, it is a really bold promise. The source lays out this beginner-friendly, fast execution strategy that is just perfectly tailored for quick learning. No heavy theory, no endless academic lectures, just pure practical application. We're looking at a roadmap that cuts right through the noise and gets you straight to an end result you can actually see and understand. Okay, let's dive into this. Here is our exact roadmap for this rapid builder's journey. 1. Intro to machine learning. 2. Tools and data loading. 3. Pre-processing and splitting data. 4. Training your model. And finally, 5. Predictions and visualizing results. All right, moving right into Section 1, Intro to Machine Learning. And this brilliantly illustrates the core concept. Our source uses this incredibly relatable, real-life example to define machine learning and specifically the concept of linear regression. Think about it for a second. How does the area of a house actually relate to its price? Well, generally speaking, a 1,000 square foot home is going to cost less than a 2,000 square foot home in that exact same neighborhood. As the area increases, the price increases. Linear regression is simply the mathematical way of drawing a straight line of best fit right through data points that show that relationship. Instead of explicitly programming a computer with hard and fast rules, we're feeding it historical examples of house areas and their corresponding prices, and we're basically letting the machine figure out those invisible rules completely on its own. Section 2, Tools and Data Loading. Let's take a quick look at your Python workbench. We literally only need exactly 5 essential libraries for this whole blueprint. Python serves as our base language. Then we bring in pandas, which kind of acts like a super-powered spreadsheet tool to manage all our data tables. We use NumPy for those lightning-fast numerical calculations running behind the scenes. Matplotlib is our artist. It draws out our final visual graphs. And finally, Scikit-Learn. This is the absolute crown jewel, which contains the actual pre-built machine learning algorithms. This simple open source stack is literally all you need to get your model up and running. So once our tools are ready, we load in our CSV dataset. Now, a CSV is really just a simple text file full of rows and columns. But how do we actually know what we're looking at once it's loaded? Well, our source highlights 3 really quick, powerful commands. First up is head, which lets us peek at the first 5 rows of our data, just to make sure it, loaded right. Next is shape, which tells us exactly how many rows and columns we have in total, really giving us the sheer scale of our dataset. And finally, describe. This instantly calculates a math summary, giving us the averages, minimums, and maximums of all our columns. This is how we start identifying our input features, like the number of bedrooms and our target variable, which is that final house price we ultimately want to predict. Moving right along to Section 3, Pre-processing and splitting data. It is time to clean this data. Here are the exact sequential steps for data pre-processing laid out in the blueprint. First, we absolutely have to handle missing values. If a house in our dataset is missing a square footage number or maybe a price, we either have to fill in that blank with a really smart guess or just drop the row entirely. Otherwise, the model will crash. Second is feature selection. We only want to pick the data points that actually influence a house's price. Finally, we create X and Y. In machine learning terminology, X represents all our input features, so the area, the location, the bathrooms, and Y represents our specific target output, the price itself. Cleanly separating the inputs from the target is absolutely crucial for this next step. Now, what's really interesting about this is the 80-20 train test split rule. Look at this breakdown. We take our beautifully clean data and we intentionally slice it up. We give 80% of it to the model so it can learn, study, and find all those hidden patterns. But we hold back 20%, the testing data. Why do we do this? Well, think of the training data like practice exams. If we test our model's accuracy on the exact same practice exams it literally just learned from, it's basically cheating, right? It just memorized the answers. We have to hide that 20% so we can test the model later on, completely unseen houses. That is how we prove it actually learned the underlying logic of real estate pricing. All right, section 4, training your model using linear regression. So the absolute crucial point here is the .fit command. Seriously, in the Scikit-Learn library, this simple, tiny line of code carries an insane amount of power. When you type .fit and pass in your training data, your X and your Y, this is the exact moment the model learns. Behind the scenes, the computer is rapidly crunching thousands of numbers, calculating gradients, and drawing that perfect mathematical line of best fit. Once that command finishes running, your model is officially ready. I mean, it's absolutely amazing that decades of complex mathematical theory basically boil down to just a few simple characters of code. And finally, section 5, predictions and visualizing results. Let's see how accurate our model actually is. So, how do we know if our model is, well, actually any good at predicting house prices? We interpret the final results using two key metrics, MAE and the R-squared score. MAE stands for mean absolute error. Simply put, it tells us on average exactly how many dollars our predicted house price is off from the real actual price. If the MAE is low, we are doing great. The R-squared score, on the other hand, acts kind of like a grading scale for our model. A score closer to 1.0 means our model's predictions align almost perfectly with reality. It is the ultimate reality check for our newly built predictor. But to truly grasp that reality check, we really have to visualize it. Comparing the actual prices against our model's predicted prices is incredibly revealing. If our model were completely flawless, every single data point would sit exactly on a straight diagonal line. But, the real world is messy. The physical distance between where a point actually sits and our perfect straight line visually explains the whole concept of error. It lets us see instantly, literally at a single glance, where our model overestimates or underestimates the true value of a house. And that brings us to the end of our 15-minute blueprint explainer. The source material leaves us with this really fantastic challenge, summarizing the whole project beautifully and asking, are you ready to check the code in the description and build your own model? It is one thing to hear these concepts broken down, but it's an entirely different experience to run it yourself. I highly encourage you to go grab that code, hit like and subscribe if you enjoyed this efficient breakdown, and most importantly, start building. The tools are completely free, the steps are logically laid out, and the sheer power of machine learning is sitting right there at your fingertips. What will you predict next? Thanks for joining me on this explainer and keep learning.